Section 2 is going to look at probability with permutations and combinations. We're going to spend most of our time with permutations, and then we'll briefly talk about what combinations are. So if you have your calculator, you might want to take that out because there's going to be quite a bit of stuff that I'm going to need to show you on your calculators. So first off, what is a permutation? A permutation is an arrangement of objects where order is important. So some scenarios where order would be important. Running a race, I definitely care about finishing maybe first before third. Standing in line, I'd rather be towards the front of the line rather than the back of the line. So that would be where order might be important. One of the ways that we can understand permutations is this idea with factorial. And they use an exclamation point to represent what factorial is. I'll give you an example using a number rather than what they use here. So if I ask you to find the value of 5 factorial, I'm asking you to start with the number 5 and then multiply all the way down until you get to the value of 1. So this is how I would represent 5 factorial. Your calculator does have a button for this, and I recommend that we use it so that way we don't have as much computation to do a lot of this stuff. So mine is going to be under the math category in here. A lot of you are going to try and find this PRB. PRB stands for probability. We're going to live under that scenario. And you can see it's number 4 for me. So if I would plug this in, I'm going to go back to the home screen. If I wanted to type in 5 factorial, I would go 5. And then I'm going to go under math and go to number 4 in there. Excuse me, I'm not over in probability. There we go. Go over to number 4. Type enter, and that would give me 120. And if I type it in the long way, it should also get me the same answer, which it does. Okay, so that's what a permutation is and factorial is. So let's try an example that goes with this. So this one, Janice and Renee are members of the lacrosse team. If the 20 girls on the team are each assigned a jersey number from 1 to 20 at random, what is the probability that Janice's jersey number will be 1 and Renee's will be 2? Okay, so one other thing that we need to talk about that your book kind of brushes over. When I talk about the idea of probability, probability is a number that is going to be between 0 and 1. So it's a percentage, it's a decimal, it's a fraction. It's going to be a number that's not bigger than 1, but not less than 0. So to calculate probability, we're going to say that we want a number on top and a number on bottom. I'm going to start with on the bottom. On the bottom, we want our total possible outcomes. We want our entire sample space. And then on the top, this is kind of harder to represent, but this is what I want to happen. Okay, so I need to find 2 numbers. I need to find the total possible outcomes, and then I need to find what I want to happen. Okay, so in this example, if I have 20 girls on the team, we're going to start with total. I'll put want, and I will put total in here. Okay, so if there are 20 girls on the team, each assigned a jersey number from 1 to 20 at random. So that means that any girl could get jersey number 1, any girl could get jersey number 2, any girl could get jersey number 3. So if the first girl comes in and she says, I want to pick this jersey number, she has 20 options when she goes in. Once she picks a jersey number, the next girl comes in, she has 19 options to choose from. Third girl comes in, she gets 18, and then you can start to see the pattern. We get all the way down to the value of 1, which means that we can represent this as 20 factorial. Okay, then for what I want to happen, this is where it gets a little bit harder to understand. Chanis wants jersey number 1. Okay, so Chanis has jersey 1. Okay, and jersey number 2 is taken by Renee. That means those are locked in. There's only one outcome. Chanis gets 1, Renee gets number 2. The third girl comes in, she has only 18 options to choose from. The fourth girl comes in, she has 17 options to choose from. And so on and so forth, and we're all the way down to the value of 1. So want would be 18 factorial. So to plug this in your calculator, you're going to take 18 factorial over 20 factorial. Okay, you don't have to do it that way. In terms of plugging it into your calculator, but I would recommend doing that so you get used to finding the factorial button on your calculator. Divided by 20 factorial. It's going to get you a decimal when you do this. I'd really recommend that you turn it to a fraction. So for me, I'm going to go math and then fraction, and it's going to get me 1 over 380. That would be my probability for this scenario. I've got one more. We'll try it. Okay, so in the opening paragraph, what is the probability that Troy is chosen to stand at the far left and Davian on the far right of the photograph? So 4 people. Lena, Troy, Davian, and Mary are being positioned for a photograph. There are 4 choices for who can stand on the far left, leaving 3 choices for who can stand in the second position. For the third position, 2 choices, yada, yada, yada. Okay, so we want to find the probability that Troy would stand on the far left and Davian on the far right. So I need a total and I need a want. Well, since there are 4 people, the total would be 4 factorial because they can all stand in different spots. For my want, I want Davian on the far left, or excuse me, I want Troy on the far left and I want Davian on the far right. So those 2 positions are taken care of. The other 2 positions in the middle can be any of the other 2 people. So that we would represent that as 2 factorial. 2 factorial over 4 factorial, when you plug that into your calculator, would come out to 1/12 for your probability.